Welcome back to the show. Today I'm thrilled to have Nick White with us. Nick is the Vice President of Celestia Labs, the team behind Celestia, a groundbreaking modular blockchain network that's redefining data availability for blockchains. Nick, thanks for joining us.
Peter, I've known you for so long and I've been watching this podcast as you've been developing it. So it's a pleasure to be on. And, I've always had a lot of respect for you. And you have a lot of insights. So I'm excited to dig into everything.
I am too. Yeah, as you mentioned, we've known each other for a long time and have watched you guys from the sidelines, and Celestia is doing a great job. And so congrats to for everything you guys are doing as an entire team. You guys as a team, you guys are killing it. Let's start off with the the problem that Celestia was initially kind of formed around. Maybe you can describe for us that problem and like maybe give us a sense of like how big of a problem it was and then Celestia as a solution to it.
Totally. So, when I first got into crypto, which was in 2017, 2018 era, everyone was super optimistic about the future of blockchains. And there's so many ideas, not just, uh, you know, bringing finance on chain or NFTs or, there's just like decentralized social media. Like there was just so many things. But then very quickly we hit the wall of reality, which was that the infrastructure just could not support even like a fraction, even like a hundredth or a thousandth of like the vision and ideas that people had. So I've kind of been fascinated from the very beginning about how do we solve building the infrastructure that can actually support crypto applications at scale and at maturity. And so that's what I've been working on. That's, we worked together at Harmony, which was trying to solve that problem. I then moved on to join Celestia, and Celestia is solving that same problem, which is like, how can we build the underlying blockchain that's the right fit for the end game of how applications will be built and how they'll be scaled. So we need to have, there's a few problems to solve within that. And I would just say focus on two that Celestia really is targeted towards. The first is just scalability. How do you build a blockchain that can increase its throughput in a way that still like preserves the underlying, verifiability and decentralization? And so Celestia is solving that problem using a technique called data availability sampling, which was like a genuine breakthrough in like crypto scaling technology. Kind of for the first time solved the big block problem, which raged in Bitcoin, then moved to Ethereum, and frankly, was never really solved. It was just always just kind of kicked down the can down the road with solutions like Solana that just require more like higher node requirements and do make the nodes more efficient, but overall don't solve the underlying same core issue. And then the second problem that Celestia is designed to solve is how do we build crypto applications in a way that they can be even more powerful and provide like more features and better UX. And that's where this idea of application specific chains comes from, which originated in the Cosmos ecosystem. And Celestia borrows a lot of inspiration from Cosmos. But the idea there is that if you're building an application as a smart contract, that's a very similar model to, for example, shared web hosting. If you're building a web app where you're building your application and running it on someone else's server where they have defined a bunch of constraints for you, and you fundamentally just can't actually, there's only a certain limited set of things that you can customize for yourself versus building in a cloud computing paradigm where you can show up to AWS and say, this is how much compute I need. This is the exact sort of specifications that I want for my virtual server. And it gives you just so much more customizability. And so that's what an application specific chain is basically your own dedicated server where you can define the execution environment. You can define, you can make it private. You can make it just tailor made to a very specific thing, like on-chain trading, like a club, like we're seeing a lot of that. We can probably talk about that a little bit later. You can make the economics and the gas fees and fees in general better. You can use different cryptography that allows you to integrate more natively with a phone, so that you can sign using things like Face ID and biometric stuff, or integrate natively into the secure enclave on a mobile device. So all these things that get unlocked when you are building your own blockchain. And so Celestia is, the problem with Cosmos is that if you had to deploy your own L1 completely from scratch, that's a huge amount of overhead. But thanks to this other innovation, which I would pair as very complementary with this data availability sampling that I talked about, is this innovation called rollups, which is essentially the equivalent of the innovation of virtualization that enabled the cloud revolution. That's what rollups. Rollups are basically virtualization for blockchains, where you can run a virtual chain so that means you don't have to build out your own data center or your own, physical servers in your office. You can rely on something like AWS, or in the case of blockchains, you can rely on something like Celestia. So that's like the high level problem that Celestia is solving: scalability and building really customized, vertically integrated, powerful applications.
That makes sense. Let's go back to data availability sampling. Could you describe, maybe walk us through what that looks like, what's involved in that, and why is it a breakthrough?
Yeah, so one of the problems with the term itself is just data availability sounds like data storage, which sounds very unimportant and kind of like whatever, that's just a back end thing, and it probably is not very critical to the functioning of any application. Like, it won't really matter. But actually, what data availability is central to what blockchains are and the guarantees that a blockchain gives you. So blockchains are essentially verifiable computers. So and what you need to ensure that whatever computation is happening is verifiable is everyone needs to agree on and have access to a shared set of transactions, or instructions that are basically being fed into that computer. And what that means is that everyone needs to have a shared view and public access to this set of transactions or instructions. That's what data availability solves. It basically is like a place where you can post transaction data and get guarantees that it's been published and is available to anyone that's part of the protocol and that has, is connected to it. So you can think of it as like this magic billboard, essentially, of like, there's data that you need to make sure gets out into the world so that your application is verifiable, and Celestia is a service that does that. And so it's essentially the same thing as what any L1 does, except that most L1s do that, but they also actually execute the transactions on top of that. So they will not just post and publish the transaction data, but they will interpret it and say, okay, these are the transactions and this is the output. In Celestia's case, we don't handle that second part. It's just a raw log of posting data, and anyone can layer on top of however they want to interpret that data. And that's what gives people the flexibility versus a standard L1 like Ethereum or Solana. It's like, we speak this one language, which is the EVM or the Solana C-level VM. We're not able to speak anything else. Like, you send another transaction in a different language or, in a different model, and we don't know what to do with that. And Celestia basically says, we don't care what you want to post. You can post anything that you want, and it's up to you how you want to interpret it. So that's basically what data availability is. It ensures the verifiability and security of applications, and it's what any L1 does. It's just, think of it as block space. Like, if we want to transact over decentralized rails, we need block space, and Celestia sells just raw block space.
Now, you guys, Celestia started this I don't know if it's a meme, but it's really a kind of a rebranding of sorts where, there's the modular chain versus the monolithic. And I don't know if I remember, I'm sure you remember, but there was a lot of Twitter spat back and forth between, you and other kind of chains that would be considered monolithic.
Mm-hmm.
Maybe, and this is all related to what you're describing as data availability. Maybe describe for us kind of like what that means, the monolithic versus modular, and how it's related to this idea of L2s and rollups and kind of Celestia's role in all of that. Because there's really kind of two movements, right? There's the continue on the monolithic side, chains like Solana, etc. And then on the Ethereum side, it's becoming more modular.
Mm-hmm.
And and this idea of interoperability becomes really, really important. But it also has some trade-offs. So maybe we can talk about all of that.
Yeah. So modularity is central to the Celestia design and thesis, and it connects to what I was sort of describing before, which is that Celestia doesn't execute the transactions. So what Celestia modularizes is basically something that's been bundled by default from Bitcoin to Ethereum, like every Solana, every single L1 that's been built up until Celestia bundles the data availability and consensus part, which again is that publishing and ordering the transaction data with the execution of those transactions. So all the nodes in the network have to do both of those things at the same time. And that's how the network functions. In Celestia's case, one of the insights of Celestia was we can unbundle those two things and just have the L1 only do consensus and data availability, and the execution part can happen on quote layer twos or rollups, essentially. And so what's happening there is you are imagine it's like you could have think of an analogy like a car. It's like someone was manufacturing cars in a way where it's like, okay, you have the chassis and the engine and they come together and they're bundled and that's it. Like you want to change the engine, too bad. It's like already, been integrated and that's how the car gets shipped. So, sorry, there's no ability to change that piece. Versus Celestia is like, you know what, we can just sell the base chassis and you can choose to bring your own engine to install on top of it. And so you're kind of modularizing these two components. And that turns out to be, again, very powerful because it's what enables an application developer to have significantly more customizability over that engine component, whether that's choosing a new kind of execution environment they want to ship, changing economics, changing the cryptography, changing the sequencing rules and capturing MEV, or like what Hyperliquid's done with adding cancel prioritizations. There's all these different, it just opens up a massive new design space where you can innovate in as a builder and make something that just frankly is not possible on a generalized monolithic blockchain. And that's the other thing is like most of these monolithic blockchains are generalized, right? So they're just like the base model, right? And it's like a one size fits all, but one size does not fit all, especially if you look around in technology, like there's always a desire to vertically integrate and customize. And so that's something that Celestia feels very strongly about. Now, the important thing is, the other part of modularity is that not only, so like let's say in Cosmos, right, you can customize the engine, but in Cosmos, everyone also has to build their own chassis, meaning they have to build their own consensus and DA layer in combination with that from scratch. And that also means that you don't share this common infrastructure. So it's a lot of increased overhead to launch your own application specific chain. And also you lose out on the ability to have this shared security, which I think is a really crucial feature for blockchains, which is that blockchain applications need to be able to verify each other. And so Celestia, that's the other flip side of modularity, is not just that okay, you get to customize the execution part, but also you can still have the benefits of this shared L1 that you get in Ethereum or Solana, where it's easier to deploy your app, and your app gets privileged access to the other apps in that ecosystem.
What are some of the trade-offs? I mean, I get the difference between modular and monolithic. For an application developer, they have increased flexibility and customizability on the modular side. But what are some, I guess, could be perceived as negative trade-offs from their perspective?
Yeah, I would say the main trade-off is that when you're launching your own chain, like a rollup is its own chain, it's difficult to move assets to and from that chain. And it's also difficult for that application to compose with other applications. And the reason for that is that blockchains, like interoperability, is still a relatively new field in blockchains. Like we know how to do it. That's kind of one of the problems that rollups solve, is they enable you to have this bridging that's extremely secure in theory, but it's proven to be much more difficult to build that in practice. And we do have ways of the other issue with interoperability between blockchains currently is that it's slower, right? So if I'm doing some kind of DeFi thing on one chain, and then I want that to connect to another chain, and maybe be able to borrow against that position, or I'm not sure, some kind of cross-chain action. It will probably, like, I can do that action on this chain, but it might take a while for that then to be able to get over to the other chain to be received, whether that's moving funds or, just verifying that I did some action on the source chain for the destination chain to be able to verify that and then take action. So then from a user experience perspective, things slow down. Versus the really nice thing about monolithic chains, or these shared just execution L1s, is that you get that composability for free in a very low friction way. And so that's kind of the benefit. But again, the cost there is you lose out on the customizability, and also there's scaling issues, which is like if you're co-locating every application on one single computer, it's sort of like your laptop, where if you have too many apps running at the same time on one computer, you run out of resources and things start to freeze up. And we see that happen on Ethereum. We've historically seen that happen on Solana. So those are sort of the trade-offs. And I will say, what's very bullish on the modular front and the application-specific chain and rollup front is that all the interoperability problems are known how to solve. It's known how to solve them, and the technology to solve it continues to get better, like every month. And so to me, it's only a matter of time before we get there to the point where the interoperability is good enough where, as a user, you don't notice, you would never know that these applications you're interacting with are on different chains, because it all feels like one unified experience. And that's something that Celestia is working on, something that a bunch of different teams across the ecosystem are working on. Specifically, one big unlock is going to be real-time proving, which is like ZK teams continue to make just insane leaps and bounds of progress. And so we're getting closer and closer every day. The intent-based protocols also enable a lot of very smooth UX. So that's what I would say is the main trade-off currently of modular, but it's a trade-off that I feel like is trending in only one direction, which is it's getting better and better. And at some point we will, I think, hit feature parity or like UX parity with monolithic chains, at which point there won't be a trade-off. So it's a question of how long will it take for us to get there? So far, it's taken longer than I think most people expected.
When I met with Jill Gunter a couple of months ago, she gave the analogy of the Cathedral and the Bazaar, and made the comparison that monolithic chains it's the cathedral, and then the bazaar, it would be these the modular side. Do you agree or disagree with that analogy?
I strongly agree with that analogy. Yeah, it's something that like thought a lot about at Celestia. And because like things, I think it's sort of like a free market for infrastructure is one way to think about what modularity enables, where it's like, so think about like in the history of Ethereum, right? One of the issues with a monolithic chain like Ethereum, and even now we're seeing this with Solana, is that you have so many stakeholders and they all have different needs. They all want different features to get added into this shared computer, right? That some people want to, add something with account abstraction. Other people want to, change the gas fee for a specific operation or remove an operation altogether or whatever. There's all these competing, or some people want to make the consensus faster or whatever. There's so many different, like kind of oftentimes opposing agendas.
Mm-hmm.
And so then it becomes very difficult to actually move forward. And in fact, you can't please everyone. Again, this is the issue of a one size fits all model, is that whichever direction you're going to go in, you're probably going to screw over someone else. You can't please everyone. And then that's also what leads to the things just moving very, very slowly. And so that's why people have launched alternative L1s since the beginning of time, because they're like, oh, well, this will never get shipped in Ethereum, so we need to do this ourselves. Now, the beautiful thing is with rollups, you can launch your own L1. You can take the EVM and modify it and add your, whatever specific change you wanted. And you're not gate kept by the core Ethereum dev like pipeline, right? Or the politics. So you get to innovate permissionlessly at a layer that you previously couldn't. And you can iterate faster. And all of a sudden you create, like I was saying, this sort of like sort of free market for infrastructure where it's like, well, if this is better, we'll try it out on a roll up. And then if it wins, that's going to proliferate. But like in a monolithic chain, you're limited to only running one experiment at a time. You can't try both ways and then see which one is good and stick with it. You can't like A/B test. Like you have to do everything in theory and be like, well, we think that this is the right change and that's what we're going to go with. So it's just like so much fundamentally better. And then the other beautiful thing too, the flip side of this Bazaar versus Cathedral thing is that L1s, like Bitcoin, is one of the reasons why people love it so much is because it's ossified to a large degree. That's kind of bearish in some ways because like they won't innovate, but it's also very bullish in that like that it's a stable foundation, right? You don't have like politics influencing it. And the beautiful thing is when you remove a lot of the things that developers want control over out of the L1, like what Celestia has done, and you just focus on something that's very pure and well-defined, like data availability and consensus, you remove that risk and the governance and the politics from the L1, and the L1 can be very stable and ossified in the sense of what it doesn't change. The underlying technology will continue to get better, will continue to scale the blockchain, but like Celestia can be this very stable foundation that everyone can build on and trust that is going to be around in the future and not going to rug them or change things from under their feet, which you can't really say for an Ethereum L1 or Solana L1 or any kind of monolithic chain. They're going to have to continue to change.
I want to talk about customers and product market fit in a second after I'd like to discuss kind of the positioning of Celestia, because I believe, Celestia was positioned initially as very complementary and helpful to Ethereum L1. But I think things are transitioning to where it might even be competitive at this point. Am I mistakenly thinking that, or?
I mean, I think that there's an argument to be made there, in the sense that I do think in an abstract way, every L1 blockchain is going after the same ultimate goal, which is to be this, what I call a security zone, which is essentially a place where it provides this base level of security to applications, and this notion of shared security between those applications so they can interop with each other in a privileged way. So in that sense, every L1 is competing with each other. Now, but then like, it's a very big universe of different designs. And it's also extremely early in the entire arc of crypto's development. And so I think that it's not that useful, at least in this current situation, to think of like Celestia as a competitor to Ethereum, because I think they're going after, like, Ethereum started as a very monolithic chain, and then they realized that modular is the right way to do things in the future. And they're slowly kind of like moving more towards modular, but they'll always kind of, I think, be kind of like monolithic. And I think just move slightly slower because of the fact that they're just bigger. They have a lot more, stakeholders, a lot more like things to worry about.
Yeah.
And Celestia, starting from the almost maximally modular point of view, building towards what we think the end game is based on the innovations of DAS and rollups, and is just able to move faster and have significantly more scale than Ethereum. But it's like, there's still different value props. Like, Ethereum is a really good settlement layer, and like, settlement is not really something that Celestia is going after. And yeah, so I feel like they're choosing different points in the design space in a way that doesn't really make them directly competitive. And frankly, the other thing is, a lot of these, so there are a lot of Ethereum L2s that are using Celestia for data availability because they don't have any other option. And in a sense, it's like, so Celestia is not really taking market share from Ethereum. It's more so an outlet for the excess demand that Ethereum can't meet because it currently doesn't have the scale to meet. But a lot of these L2s are still very much aligned with Ethereum and branded alongside Ethereum, and using Celestia for DA because we're the best alternative. But it's not like that. I don't consider that as like stealing market share from Ethereum.
Yeah, I think that's a good framing, that, Ethereum, there's so much demand that Ethereum can't meet. And so Celestia, handles that and is able to meet the excess demand. Let's talk about that. Like, how do you think about customers? You've mentioned rollups and L2s using Celestia data availability, and maybe share with us kind of like what, I guess, where things stand in terms of Celestia's customers.
Yep.
And what product market fit looks like, and has Celestia reached product market fit?
Yeah, I think that Celestia has a very early version of product market fit, in the sense that there is a lot of demand for people to deploy application specific rollups, or just rollups in general. And Celestia is the best data availability on the market, the best solution for that on the market. And so we are kind of the default place where, if you're launching a new rollup, you choose Celestia as your data availability option. Now, the issue is that for Celestia, I think, to have genuine product market fit, or for it to really feel like, okay, this is really going to work, we need an application on top of Celestia that itself has product market fit to some degree, right? And I mean, ironically, the entire space is there's a very limited set of apps that have really hit that so far, and so that's, I think that's one of the challenges, is like, whenever you're building infrastructure, it can feel like you're dependent on the actual adoption of applications for your infrastructure to have real adoption. But Celestia is really a bet on the fact that we will see massive adoption of blockchain applications, and it's only like a matter of time. And when that happens, Celestia will be there to provide the block space for all of that verifiable compute. But where we are today, we have I think over 50 rollups deployed, on Celestia, which is pretty good given that we've been live for a little over a year and a half. Some of the names that people might recognize are teams like Abstract, which is a consumer-oriented L2 built by the team behind Pudgy Penguins. And also Athena is deploying this really exciting RWA and so stablecoin, like institutional DeFi chain called Converge in partnership with Securitize. So those are a couple of of the larger chains that we're really excited about going live. We have, aside from that, a bunch of DeFi and RWA chains alongside that, things like Derive, which is absolutely crushing it in the on-chain options area. I think they're kind of the hyperliquid of at least options trading. Things like Plume Network, which are RWA focused chain. They have like 200 million TVL. And then we have a whole list of, there's a stablecoin payments app. There's Noble, which is its own sort of like stablecoin, yield-bearing stablecoin issuance layer that's building a application layer on top of Celestia. So there's like a whole, it kind of like goes out very far and wide from there. We're really, I should also mention Hibachi, which is actually trying to compete with Hyperliquid. So one of the application categories that has reached product market fit that Celestia is very bullish on, and we think Celestia has a chance of playing a very big role in, is this sort of on-chain CLOBs, which is central limit order books, which is essentially the infrastructure has now gotten to a point where you can build a decentralized exchange that gives you feature parity and like basically the same UX as a centralized exchange like Binance. And so Hyperliquid's proven this out. Their volume is just growing massively. And now there's a bunch of teams that are following that and trying to build and innovate even more. And so we're working with a handful of teams there, Hibachi being one of them, where one of the things that they've innovated on, not only is there faster, lower latency than Hyperliquid, but also they add a layer of privacy. So again, that's something that you can do when you have application specific control. You can be like, oh, well, I want to make sure that the user data and the trades are private rather than being published on chain, because that's something that happened with Hyperliquid, where this trader James Wynn claims that he got, his position got hunted, and that's why he got liquidated. But CLOBs are something that we're very bullish on as like one of the first like crypto apps that have really hit meaningful product market fit and are going to grow significantly from there. And they need a lot of DA, because every trade that's like 100 bytes or 150 bytes or whatever needs to be posted on chain for some of these exchanges the way they're designed. So that adds up to like just thousands and thousands of TPS.
That's exciting. When I think of product market fit for Celestia, I've worked with a number of L2 teams, and every single one of them use Celestia for data availability. And I think that speaks pretty highly of Celestia as a service. And I think there is, really meaningful product market fit from that perspective. Mm-hmm. That L2s, rollups, they use Celestia underneath. And I think that's huge. Now, to your point of, Celestia itself creating an application that uses Celestia, I think that's quite interesting. And I'd love to hear more about that. And I think Hibachi is very exciting. And I believe they're using Celestia underneath as well as Succinct to help with the privacy stuff, right? And so that's actually quite exciting. Tell us about Celestia has saved these rollups a lot of money, and which is very meaningful. Maybe give us some numbers around that and why that's important.
Yeah, well, especially in the early days before Ethereum sort of shipped EIP 4844, which created the sort of blob market for like Ethereum blob space. So it expanded Ethereum's DA capacity. A lot of the teams that we were talking to were spending, millions of dollars annualized or even monthly on just paying for data availability on Ethereum. So that was when there was only call data, and there was just not enough of it to go around. So, the rollups had to pay that much to Ethereum, and so it was very difficult. If sometimes, well, first of all, it eats into their profit margin, and also in some cases made it so it's like unprofitable or like just a massive cost to just run their infrastructure. And so a lot of teams migrated to Celestia around then, and immediately were saving, millions of dollars that they could either pass back to their users as lower fees or through some kind of incentives, or that they could keep for themselves, and reinvest into further development of their product. So I eventually Ethereum shipped 4844, and the cost savings compressed, but they're still there. So I think Celestia is now about 40x cheaper than Ethereum, even post 4844. So that's still very meaningful. Now the thing is, then the funny thing is, there's other DA layers who in the past had been saying like, oh, well, we're going to do DA that's another 50 times cheaper than Celestia, right? And a lot of people were mistaking this idea of like, well, you should always, like, anything that's cheaper is always going to be better, right? But that is only true up until a point, right? And so like even right now, I would say that Ethereum blob space, it's cheap enough that I don't think the incentive is to necessarily move to Celestia, even though it's 40x cheaper. For some use cases it is, and we have actually quite a few builders who do move over. But if you're a base or an Arbitrum, you're already making enough money that the cost that you pay to Ethereum for DA is such a small fraction of like your overall operating expenses that it doesn't really matter. It's like, what's the reason for us to migrate to something that's cheaper? Not now. A lot of smaller teams, it is a very meaningful amount. So those teams are moving to Celestia because it matters. But again, like after a certain point, once the cost of using the DA is a small enough fraction of your overall spend, I feel like it no longer matters so much as these other things, like how reliable is this DA layer? How easy is it to build on? Is it integrated with the rollup framework that we want? Is it integrated with the rollup as a service team that we're working with? There's like a whole set of other considerations that become significantly more important than just raw cost. And that's also where Celestia shines, is we have, I think, the best developer experience, we have the most integrations, and we have just a really like strong brand, and reliable, like highly reliable like service. And that's what people care about. Like reliability is a big thing, because it's like you don't want your application to crash because like the underlying DA layer went down. And so that's another thing that Celestia has as a first mover, kind of, and being one of the longest running DA platforms.
Yeah, it's been said that the first in the category is going to be the winner, and they will, own a really meaningful, share of the pie. And I think Celestia is one of the shining examples of that in crypto, is that it was like the category creator of data availability, and its brand is super strong. I think distribution is really great. Maybe let's talk about distribution. I believe one of the main ways that Celestia is kind of distributed to, or is available to developers, is through rollup as a service providers like RAS. Is that correct? And what are other ways that developers are learning about Celestia?
Yeah, so rollup as a service. So for people who don't know, rollup as a service provider is sort of like, you could think of them as a sort of system integration layer, where like, or like a white glove service that makes it so that if your expertise is not in deploying infrastructure or even choosing what infrastructure to use for your application, you can go to these teams. They know the full suite of products. They have built out the technology needed to deploy these things in a very robust way. And you pay them, there's different cost sort of like structures for this, but you pay them for this service, and it makes it very like turnkey and easy. And it kind of does feel like if you go to, for example, Conduit or one of these like Gelato or Caldera, a handful of the names of the teams that we work with, if you go to their pages, it looks very similar to AWS in the sense of you have this interface, and it's like you can click a few buttons of like, here's the execution like roll up framework I want to use, here's the DA layer I want to use, some other customizations, and then click deploy. And so it's like a no code tool for deploying your own chain, which is pretty crazy. And that's always been the sort of vision for modular blockchains, is like make it as easy to deploy a blockchain as it is to deploy a website. And that's how we unlock a lot of like innovation that is currently held back. So anyway, roll-up as a service teams are a big way that we get distribution, because they're out there kind of like selling on behalf of Celestia to teams. But I've been surprised that a lot of the teams that are, especially the really high value teams, they're fine with running their own infrastructure and hiring people, or getting the right talent to deploy their own infrastructure. Now they still don't want to deploy their own L1. That's like way too much work. But they're very happy to build things themselves a little bit more directly. And even there are a lot of teams where they don't even want to use a roll-up framework. They want to do a completely custom thing from scratch. And that's also what gives them an even more higher degree of customizability than like you even using like a pre-existing roll-up framework like Arbitrum or what have you. And so I'm actually seeing a lot of the highest quality team. What I'm trying to say is a lot of the highest quality teams come directly to us with their own thing. And that's actually another way that Celestia shines, is that we have an extremely good solutions engineering team that like has done a lot of has like the deepest expertise in this technology stack, not just Celestia, but all these different rollups, all the ways in which we can build these things, and we're extremely good at giving like one-on-one engineering help to make integration successful. So for example, Abstract, we're putting a lot of effort there into completing an integration, as an example. And so like we have a lot of, I would say, like edge there. And I think that matters a ton, because these high quality teams, they want to work with the best too. They want to work with the best engineers. They want to work want to use the best product. And it's not about cost so much as it is like, will this platform and this team that I'm working with help me to succeed?
Which really speaks to the strength of the brand and why having a strong brand matters so much, because it acts like a magnet for new customers.
Yeah.
And that's really what I'm seeing from the outside. When I speak with L2s and rollups, they're inevitably they end up choosing Celestia because it's such a strong brand. Let's kind of pivot to a couple of spicy takes that you've said on X. And I'd love to hear your thoughts on that. So you tweeted that EVM and SVM were just detours on the way to ZKVMs. Can you maybe you mentioned it a little bit, but I'd love for you to expand on that.
Yeah, sure. So I think so. EVM, SVM, that's Ethereum virtual machine and the Solana virtual machine, which are currently the two most popular ways of building applications. And essentially those are, as I said, kind of like constrained environments in which to build. Like they make a lot of decisions for you that are just baked in. And that means that you're as a developer, you're pretty limited. And there also could be a lot of stuff that you don't need that's like bundled in there, and it's just there because it's there. That's like the standard package that you get. And what ZKVMs are is essentially a way to you can write an application just the way you would write a normal like computer program, which is like just in like a language that everyone else would use, like Rust, for example. And then that can be fed into a ZKVM, which makes it verifiable and proven. And so I think it's just frankly, a much more natural fit to how developers, like meeting developers where they are, rather than trying to force them like, hey, learn this new language, like learn Solidity, learn this whole new thing, and then you can build applications. Instead, it's like, oh yeah, well, just, I mean, whatever language you want to write it in, do that, and then the ZKVM takes care of the rest. So it's just like a much more straightforward developer experience, I think, and will just lead to people building these verifiable applications in much simpler, lower overhead ways. And like the thing is, like the effort the reason we couldn't get there right off the bat is that like building these generalized ZKVMs is like an extremely hard engineering problem, and making them flexible, making them super performant. There was just a huge amount of innovation that had to happen. And that's frankly happened much faster than I think anyone would have imagined. Like, if you rewind 5 years to 2020, even the people who are the most bullish about ZK, I don't think they would have thought that we would get to where we are today, where we have these very generalized ZKVMs that, you can like almost verify anything inside of, and that they're extremely performant at the same time. And like the trajectory of how fast they're improving is like very, very exciting.
Yeah. I remember working with a couple of ZK teams, and I mean, they were still at a point where they had to create their own circuits, right?
Yeah.
And then teams like Succinct and ZK Cloud and Risk Zero, now it's like really easy for developers. Like, they've made it really easy for developers. They've abstracted a lot of the complexity away, and
Yep.
now it's like ZK is very it's like down to earth. Like, they've made it kind of like actually kind of sexy,
Yeah. Yeah.
which is great.
And the thing is too, by the way, that this is extremely bullish for the modular worldview, because like now it's not just, it just makes it so that the amount of creativity and flexibility the developer has at their disposal is like that much more massive. And it solves this interoperability problem where if every app is just written as a ZKVM app, then it's provable by default. And so it becomes very easy for you to take this application and then plug it into another application, because they can verify each other very easily with ZK proofs. So it's just it's just unbelievably bullish for modular.
Awesome. Well, Nick, this has been a really enlightening conversation. Thanks for breaking everything down and then speaking to us from first principles. Before we get off, what are some things maybe you could share with the community that you guys are focused on, very prioritized in building? What can you share with the community?
So there's a lot of really exciting things happening in the Celestia world. So I'll try to just quickly summarize them. One is the whole clobs on blobs thing, which we talked about, which is we're working with a lot of teams that are building these next gen clobs. And from that, we foresee a lot of demand for block space. And so we think we're at an inflection point for Celestia, for the demand of Celestia's block space. And so it's going to be very exciting to see how that all plays out. So people should stay tuned on that. We're also working on some big economic overhauls. So very soon we'll be shipping an upgrade called Lotus, which decreases the inflation of Celestia. It also makes it so that Celestia, the TIA token, can be bridged much more easily to other chains and rollups in the ecosystem, because like the TIA token so far has kind of been trapped on chain because it only has IBC support. So it's another big one that's coming out soon. We have the next upgrade that's coming out is going to be a massive upgrade to our scalability and our throughput. It should get us within the range of 20 megabytes per second. Eventually, first 5 megabytes, but then with further like on-chain governance, we can upgrade to 20, which will be huge. And we're also exploring this idea called proof of governance, which people should check out, where we think we can actually reduce the issuance of TIA from where it is today, which is currently around 7%, to roughly like 0.25%. So what that means is, like, if you think of these protocols as like these economic engines, the issuance is sort of like a drag on the economy. It's like the deficit. Like, if people are paying attention to politics, it's like you can either have a surplus or a deficit, and the amount of spending is linked to how much inflation that you're, putting out there of the token. And if you decrease the inflation significantly, like down to 0.25%, then the amount of revenue you need to generate a surplus is significantly lower. So we actually feel like this really increases Celestia's chances of hitting profitability in the near term. So that's going to be a really exciting thing to pay attention to.
Awesome. Well, Nick, thank you so much. Those are exciting developments, and look forward to you guys executing. And you've got my support. Thank you.
Thanks, Peter. It's great chatting with you as always.